Thank you. Thank you so much for joining us this evening for the Get More Dirt on Your Soil webinar series. My name is Becky LeBoy. I'm the Education Outreach Specialist with Ocean County Soil Conservation District. I'm so excited to be here co-hosting this webinar series with Dr. Steve Urjo, the Rutgers Cooperative Extension County Agent for Ocean and Atlantic counties. Tonight, we are continuing with our second soil webinar series, Get More Dirt on Your Soil, which is a follow-up to our first soil webinar series we offered in 2020 called Get the Dirt on Your Soil, which was a basic introduction about soil and soil health. And if you missed any of our webinars in our first series, we can put the link to the recordings in the chat in a few minutes. And these recordings can be found on the Rutgers Agricultural Experiment Station YouTube channel. And tonight we have our second guest speaker of our 2021 series, Fred Schoenagel, who is presenting an organic gold mine in your yard. And we are recording Fred's webinar, and we will be making it available also on the Agricultural Experiment Station's YouTube channel. And Dr. Urjo will be sending out an email to everyone, letting you know when it is available to view in just a few short days. So our speaker in this series was Dr. Jennifer Crumans, who presented Unearth the Life Beneath Your Feet on March 25th. Her program was not recorded, so I'm so sorry if you missed it. It was fantastic. Our third and final webinar in this series will be on Wednesday, May 5th from 7 to 8 p.m. And that program is called Breaking Ground on Composting, presented by Sandra Blaine Snow of the Ocean County Department of Solid Waste Management. And Sandra's program will be recorded, and you still have time to register for Sandra's program if you want to see it live. And I believe Dr. Urjo is going to put that link in the chat as well. So if you have any questions for Fred this evening, we ask that you type your questions in the chat feature. The chat feature can be found by clicking that cartoon thought bubble found at the bottom of your computer screen. If you don't see it, try clicking those three dots, the breadcrumbs, and then click the chat bubble. And then once you click on the icon, there's a drop-down menu in the chat panel, and you can choose who to send your question to. We ask that you send your questions to all panelists, please, so that we can all see them, and Fred will address your questions. We're so excited to have Fred this evening presenting an organic gold mine in your yard. We so appreciate you taking the time, Fred, to share this, to share your vast knowledge. Fred is a resource soil scientist with the Department of Agriculture, Natural Resources Conservation Service, so USDA-NRCS. And Fred has been with USDA-NRCS in New Jersey since 1996, where he has worked on updating soil surveys, evaluating soils for their suitability for different uses, and diagnosing problems within soils that are not functioning, and so much more. So Fred, thank you so much. Take it away.
Thank you very much, Becky. Welcome, everybody. It's very exciting to be a part of this series. I always love working with the Ocean District folks. They're always very kind and get me to talk about some really interesting aspects of soil. So I love I can't claim the topic title that was given to me by Steve, but it's very appropriate for talking about organic matter. And it's a neat title because it's kind of true. It's sort of an undiscovered value to soils that we'll hopefully explore and hopefully have you learn a little bit more about. So, first thing I want to do, just before we get into it, I always like to do a little information on what the U.S. Department of Agriculture, what my agency is all about. And our agency's been around a while, not in its current form, but it's been around in some form or another since the 1930s. And if you look down here at the bottom, 1933 was the creation of the Soil Erosion Service under the U.S. Department of the Interior. And then in April 27th, 1935, the Soil Conservation Service, or SCS, was established within USDA, which was our parent agency. It was the SCS for a very, very long time. And then in 1994, the agency changed its name to Natural Resources Conservation Service, or NRCS. And the reason for that change was that even though soil conservation is at the core of what we do, we also are preserving and protecting other natural resources: air, water, animals, plants, and along with the soil, everything working together. So we wanted to be more of an all-encompassing agency to help people out. So that was one of the reasons for the name change. And so we've had a long history of protecting the soil and working with it and trying to understand it a little bit better. So I'm a soil scientist, and the way it works is that you usually can't talk about soils unless you talk about the functions of soil. And these are basically the five possible functions, the five possible things that soils are capable of. And one, I'm not going to read these, but you can sort of look at them. But the one thing I want you to kind of think about is that in your life, in your everyday life, you may not work with soils, you may not have anything to do with soils at all, but from where you get your food from, to the buildings and roads you drive on, to the water you drink, to the water that gets treated, the wastewater and used water. Soil is really important for all of these different functions. So we essentially interact with soils even if we don't think we are, on a daily basis. And that's one reason why we want to protect them, why we study them, and why we also want to learn a little bit more about them. So the way we look at soils, we typically break them into three parts as far as properties go. And it's just a way to try to break soils apart, understand them a little bit more, because the more we understand about them, the more we can understand how to best use them, how to protect them. So for most aspects of soil science, we have physical properties, chemical properties, and biological properties. And these all contribute something to the soil. They help soil perform one or more of its functions. And to really understand soil, you need to understand all these three aspects of it, all these three characteristics. And if we take all of these physical, chemical, and biological properties and we relate them back to the functions of soil, you can see for a lot of them, things like organic matter play a part. They are a contributing factor to the ability of a soil to perform some of these functions. They don't contribute anything to something like supportive structures, because that's sort of contrary to the use of organic matter in a soil, which I'll talk about a little bit near the end. But just know that organic matter plays a part in all of these different functions of the soil. So that's one reason why it's important. It's one reason why we want to learn a little bit more about it. So I use the term soil organic matter, or SOM, and we use different terminology: organic matter, organic material, soil organic matter. I want to define soil organic matter. That's basically what we're going to talk about. It's the part of the soil where the parts of it came from anything that was once alive. It sounds kind of flippant, but it's to contrast the inorganic or the mineral parts of soil that may have been derived from some sort of geologic formation. So it includes any sort of remnants of or cast off from plants or animals, any kind of remains, cells and tissues of soil organisms that live in the soil. And we can use the fancy term exudates, substances that are exuded from plant roots or soil microbes during metabolism. And this may not sound like much, but for most soils, the organic matter content accounts for less than 5% of the soil's total volume, which doesn't sound like very much, but I think hopefully once we get more into it, you'll see why something as low as 5% is actually a great amount. So for soil science, we like to picture what would be an ideal soil. And for that soil, about half of it would be made of solid material that gives it structure, that gives it support, that gives it, that body. And almost 45% of that is made of these mineral materials, with about that 5% as organic matter, and all mixed together, working together. So half of that space is then open for air and water exchange. And in the ideal soil, you want about half that space to be water and half to be air. That way there's air for aerobic organisms, for open space, for roots to penetrate, for organisms to live. You don't want too much water, but you want some water, because that film of water helps store and move nutrients around, and helps keep the microbes hydrated. So you want a pretty good balance. In the ideal world, this is what you would get. So we're going to look at what does soil organic matter do for physical, chemical, and biological properties of the soil. So organic matter for physical contributions provides a lot. It does help hold soil particles together. So if you've heard of erosion, soil that has a high erodibility, the organic matter can help sort of hold that soil together, knit it together. It will also take up some space between those soil particles, so it may be harder to compact that soil and make it more dense. Kind of keeps it open, and by not allowing it to compact easily, it improves the tilth of the soil, especially at the surface horizon. Makes it easier to work, to till up, to prepare a seed bed. The soil itself is easier to work. Plow will cut through it more easily. A spade will cut through it more easily, and soil doesn't stick together. I know some people mentioned clay. Something like organic matter added to soil can help kind of soften up and break up that clay, so it doesn't stick together so much. Surface crusting, where you literally have a layer on top of the soil that sort of seals the soil surface and doesn't let water in. By promoting soil structure development, you don't get that crusting at the top, and plus the soil particles want to move around and settle and become a discrete layer that is a crust. By having soil structure and lack of a crust and an open pore space, more water can infiltrate or enter the soil surface, and the more water that enters the soil surface as it's flowing over the top of the soil, the more water that gets in, the lower amount of water that will run off of a site. So it keeps water on the property and not let it run off. And by keeping these the soil structure development, by allowing that to happen, it makes that pore space that facilitates penetration of plant roots. So a lot of stuff going on there, a lot of physical properties that can be improved or supported by organic matter. So here's a little example. This looks very large, but if you see the scale, it's 0.01 millimeters. A silt, these are 2 silt grains. Silt grains on average are about 0.05 millimeters in diameter. So we're pretty small here. And if you look, there are some clay particles holding these 2 silt grains together, but there's also some organic matter holding the 2 particles together. And if you see this pattern repeating for every 2 silt grains, knitting it together into a network, that's what helps hold the soil together. When you aggregate the soil into what are soil aggregates, structural PEDs, we call them, or aggregates, larger chunks of soil that occur in a repeating pattern. That soil structure, depending on its shape, can actually promote vertical water movement. So the leftmost example is what we call granular. The third from the left or the second from the right is subangular blocky. And anything that's more spherical or blocky in structure, that pore space is just in going in all directions. It's sort of like a jar of BBs or a jar of marbles. You know, you picture all the space where two marbles are not touching. That's technically pore space. If you have more of a horizontal type structure or more restrictive like prismatic or platy, the water is not allowed to move through the soil as freely, and definitely not in a vertical manner. And that pore space where the water is moving is also where plant roots can move down through. So one significant reason to build soil structure to keep soil particles in place is the Dust Bowl, or what happened back during the Dust Bowl period, which was actually one of the reasons that the Soil Erosion Service was set up in the first place, because of the rampant, unfortunate wind erosion of a lot of the soil. So this is a photo of, call it a black roller, and judging by the scale of the car versus the cloud, you can see just how much of that soil material is being moved freely by the action of the wind. That organic matter may help to hold that soil together and keep it in place, even if the wind is blowing on top of it. So the chemical properties of soil that benefit from soil organic matter include the ability to store and supply nutrients for plants and the soil organisms, the microbes. It helps retain nutrients by providing cation exchange capacity, which we'll talk about in a little bit. And one of the functions of soil was the filtering, buffering, and immobilizing organic and inorganic compounds, not necessarily pollutants, but the organic matter may help tie up some things that are less desirable within soils and keep them from entering aquifers or just leaving the soil itself. So cation exchange capacity, which is very critical for the fertility of the soil. Basically, a lot of plant nutrients and metals are positively charged. They call them cations. Some of the most common ones are listed here, including hydrogen, calcium, potassium. So clay particles, clay minerals, and organic matter tend to have a net negative charge on the outside of them, and they actually attract these positively charged cations to them. They hold on to them, but they don't hold on to them to the extent that they don't release them back to the soil solutions. So it's the action of grabbing and attracting positively charged ions and then releasing them, and making them available for plant roots especially, and that is what cation exchange provides to the soil. So here you either have clay minerals or little particles of organic matter. Here it's humus. And on this part, this is the soil solution. So there's water out here, and the calcium, positively charged calcium ion, is sort of attached to the clay mineral or the humus. And then here, sort of like a reaction, we can go to this side, and here the calcium ion is released to the soil solution. And if a plant root's in the vicinity or a soil microbe that might need that, it makes it available. And other ions may be replaced and taken off and added on. So that at that action of that attraction is cation exchange capacity. The biological contributions include providing an energy source for soil microbes, providing carbon to the soil. It retains carbon also from the atmosphere and other sources. It becomes a storage for carbon, and it aids the growth of crops because its ability to sort of hold on and transmit air and water. A water molecule is actually negatively charged and positively charged. It's dipolar, and the positively charged side of the molecule, the water molecule, can actually get attached to the cation exchange capacity as well. So organic matter can help hold on to water. And here we sort of zoom way in again, and I believe these are probably small gravels, and we go all the way down to what are clay organic matter particles, sort of holding some larger particles together. Here's a plant root, and we have some microorganisms and some larger insects, and everything sort of working together. You know, one way to picture a really active soil where a lot of things are interacting with each other is you know, what Charles Darwin called a dreadful but quiet war. You know, it's kind of an ugly place. You know, there's consumption of organisms and destruction of organic matter, but this is part of what makes the soil alive, are all these interactions and the use of organic matter, either in a fresh source, such as an exudate from the microorganisms or from a plant root, or decomposition of the organic matter, or use of the organic matter to hold soil particles together. So actually, before I go into, someone asked about tilth, and tilth is sort of it's an agronomic agricultural term, and it kind of relates to the soil's ability to be broken up by a plow or by the action of some sort of mechanical device to till the soil up, to break it up. And part of what part of the ability of a machine, a plow or a spade to break up the soil is the particle size of the soil. You know, if a clayey soil could be difficult to dig in, difficult to run a plow through, a sandy soil could be very easy to plow through, and organic matter helps a soil that maybe has a lot of clay or is compacted. It sort of loosens that soil up and makes that soil easier to work with some sort of mechanical device. And that's essentially what tilth is. It's kind of an odd phrase, but it's sort of the workability of the soil. How easy is that soil to work? And the easier it is to work, the better the tilth is. So hopefully that's defined that term for everybody. So we see the importance of organic matter, and one question to ask is, where do you get the organic matter from? There's a lot of different sources, and one of them, the most important for most soils, is the ability of plants to combine carbon dioxide and water through photosynthesis, and that produces organic compounds that are put into the soil. So soil organic matter is created by the cycling of these organic compounds. They're used by everything, by the plants, animals, by microorganisms, and it's running through the sort of carbon cycle that helps provide organic matter to the soil. It ends up being put into different forms, these organic compounds. So what are these forms? Each one of them has a name, and they're all a little different. There's humus, lignin, and cellulose. Humus is the most stable form of organic matter. It's completely broken down. It cannot be broken down anymore, and so it has the ability to stay in the soil for a very long time, on the order of thousands of years, or perhaps longer than that. It is the ultimate form of organic matter that eventually organic matter reaches, organic matter particles reach. There's also lignin, which kind of functions like a glue, for lack of a better term. It sort of holds soil particles together. So we saw those two silt grains earlier that were being held together by an organic glue, and that most likely was lignin holding those silt grains together. Humus and lignin being very small in size, they'll have that net negative charge on the outside, and they're what would contribute to cation exchange capacity to help improve soil fertility. And the other form of cellulose, of organic matter, is cellulose, which is a pretty hard molecule to decompose, and it actually must be broken down by microbes, and they tend to utilize it as a food source. But as you can see, like, it's really great to have all three of these forms in the soil because of that need for the functions of the soil to be facilitated by the three different forms. for what all they contribute to every soil. So the organic matter content of soils, how much organic matter is in the soil at any time, it's never really an equilibrium because of the dynamic properties of the microbes and the plants and higher order organisms interacting with the organic matter. But it tries to have a balance between the additions by plants and animals and losses by decomposition. They're both controlled by management activities, and we'll get into that in a little bit more. But the other thing that can also determine the organic matter content is basically the ability of the plant materials to produce through plant growth the organic compounds. So the more vibrant and lush the plant growth, the more organic compounds are produced. And so, of course, because of photosynthesis, things like the intensity of sunlight, how much carbon dioxide is the plant taking in, and the relative humidity, which may relate to cell hydration, are all affected. So it's essentially that plant's ability to produce is one of the contributing factors to the organic matter content, along with additions and losses. So this is sort of a neat diagram, gives you a little idea of the carbon cycle, and you can see some organic matter is lost on soil particles by erosion, because sometimes you still get erosion even if there's organic matter in the soil. You get some respiration of CO2 by microbes, so some of that is lost. Atmospheric CO2, depending on its concentration, is absorbed by the plants. The detritus, the loss of tissue from the plants added to the soil, that's your addition. And as this cycle goes around and around, those are your additions and losses. And this is sort of a neat publication if you're ever interested. Soil organic carbon, the hidden potential. There's all kinds of great information out there. That's a really good publication now. So we have the soil organic matter. We know the importance of it. We can see its content is balanced by losses and additions. So what kind of things are in the soil that may decrease the organic matter content? Well, this kind of makes sense if you have a decreased production of the plant materials, the plants that are actually growing there, that is going to lessen the additions to the soil. So anything that either creates a situation where there's fewer plants on the site, or the plants themselves are not producing a lot of biomass that gets added back to the soil, or actually having times of the year where vegetation is not on the ground, taken away. Those are all things that cut that supply of organic material to the soil. Someone asked, it's good, we'll jump into it right now, is it a good idea to leave fallen leaves on the ground year round? That's actually kind of a tricky question, because sometimes fallen leaves can be very beneficial, but sometimes if the cover is too much, it may actually choke out some surface vegetation. I hopefully will address that question a little bit later when I talk about adding organic matter to the soil. But if I forget to circle back to that, I apologize. But yeah, there definitely are situations where, especially if perhaps there isn't a lot of vegetative cover, perhaps fallen leaves left on the ground could take up that extra space and cover the soil surface where vegetation is not growing, as long as it doesn't obscure the vegetation itself. How much is sort of that's a question. Hopefully, I'll address in a little bit. But like I said, hopefully I will remember to finalize an answer on that one. But thank you for asking the question. The other thing you can do that will decrease the organic matter content of the soil is to decrease the supply of organic materials. So kind of sounds like what we just said, but it's more leaving that organic matter on the ground surface, at some point. Sometimes nature takes the vegetation away, or management could, if the residue is burned, it is literally removed for the most part, and the residue is not allowed to sit there and sort of go through that decomposition to break down and transform to all those different forms of organic matter that we want in the soil. Or by harvesting and removing the plant products, may not leave enough residue behind to allow that organic matter to be fully added to the soil. Now, I want to say, in some situations, harvesting or removing plant products, that's very necessary because we may want to use those for something. So I'm not saying you can't remove those things if that's necessary, or if that's part of management. That's perfectly fine to do that. It's just that know that the organic matter source is being taken away. So it's not a bad thing. It's just it will decrease the organic matter content of the soil, perhaps. The other thing that can happen, the decomposition rate of the soil may increase. So not as much organic matter is being added to the soil, but the decomposition rate of the organic matter is starting to increase. And sometimes if you disturb the soil, especially that surface layer, you incorporate the surface organic matter into the soil, the microbes will start using it as a food source and breaking it down more rapidly. Oxygen enters the soil and may break the organic matter down more rapidly. And sometimes fertilization, in addition of nitrogen, may make the microbes more active, and they'll start to metabolize and utilize the organic matter more rapidly. So,
Fred,
yes.
is this a good time to stop and answer a couple questions? We have some questions related to the content you were just talking about.
Sure, absolutely, yeah.
So regarding organic matter,
Yes.
organic matter, well, first of all, how does a person know how much organic matter is actually in their soil? Is there a way to test it?
Yes, actually, if you take a grab sample of your soil, the best thing to do would be to go on to or search for the Rutgers Soil Testing Lab, and they have all kinds of information on how to get your soil tested. And one thing they can do is the soil sample, they will help you, they will explain to you how to collect a soil sample for your site. But once you send them a sample, you can request an organic matter content evaluation, and that'll give you a sense of how much organic matter is in your soil. And people have said, oh, you can dig a soil pit and look at the soil surface, and depending on the color of it, you can tell how much roughly how much organic matter is in the soil. That gets very tricky. We'll talk about that a little bit more as we go on, but the best way to learn everything about your soil is really to get the soil tested. That way, it's all described to you, it's all explained to you, and then you know all the fertility levels and everything else. But organic matter can definitely be part of a soil test. Yeah, very good question. And yeah,
So,
yep, there's the link. That's good.
excellent. Thank you, Steve. Just put the link into the chat for the
Yeah.
soil testing lab. Super.
Mhm.
Thank you. So related question.
Yes.
We have a diversity of habitat here in New Jersey, and
Yes.
I'm sure that different habitat has different percentage amounts of organic matter. For example, the sandy pine barrens might not have as much organic matter in the soil, whereas other places might have a higher content
Right.
percentage-wise. So when the question is asked, how much organic matter, two-part question, how much organic matter should be in my soil, is kind of the first part of the question, and then should I try to amend my soil by adding more organic matter? Let's say if I live in the pine barrens, or if I have very clay soil, is too much organic matter a bad thing?
Yeah, I'm actually that's those are really good questions, and I am actually gonna address that in a little bit. So, but especially, is there such of a thing as too much organic matter? I'm actually really glad that somebody asked that question, because I wanted to bring it up, and that gives me a good excuse to bring that up later.
Good.
But
Good.
there,
Yeah.
for right now, as a little teaser, yes, there's not like a proper amount of organic matter to add to the soil, but there is sort of like, a more appropriate amount, I guess I should say. But yeah, we're absolutely going to address those questions further on.
Great.
Like I said,
Good.
that
So we'll
asking,
hold us on the answer, and we'll wait for the question. And the question was specifically, does it make your soil more fertile if you have, let's say, more than 5% organic matter? Do you have
hmm.
like really fertile
Well,
soil,
that's a
or?
really good question because yeah, I'm going to address that for sure. The
So
$5
I'll
thing.
share with you a couple more questions, and then
Okay, yes.
no need to answer them right now. You can answer them as we go. But
Okay.
one question was about turning over your soil in the spring. Is that a good
Mm,
thing or not? So basically tilling the soil. I have my own thoughts on that, but I'm excited to hear what you have to say about that. And
yeah.
then what happens to soil content during the winter time when the ground is covered with snow? Um, I, does the organic matter continue to decompose or not? So
Hmm.
that's something to think about as well. So
Those are, I know, I'm trying to think. Yeah, the tillage question we can talk about. The so I work for the U.S. Department of Agriculture, and you know, I don't like to say you can or can't do something because I did bring up, management. So if in the management of your soil tillage is necessary, it is not that you can't do it, but the some things in soil science are absolute, unfortunately. So a soil that has a lot of organic matter, I guess one thing I could say is that a soil that if is sort of prepared to lose some organic matter, where you've really have done a lot to add as much organic matter to that soil as possible without, negatively affecting the soil. When you do the tillage operation, the expectation is that you will lose some organic matter because, back, where's my cursor? Uh, what you're going to do, the decomposition rate is going to increase because you're doing to the soil, which that something that sounds really good. You're aerating the soil. You're running a piece of tillage equipment and breaking the soil up, and it's necessary because you do need to break the soil up to a certain extent to prepare a seed bed, especially depending on what you want to grow. You may need to do that. Not every plant is just going to be dropped as a seed and just automatically go into the soil. So sometimes for certain crops, you may need to prepare the seed bed. But all I can say is that any kind of tillage, unfortunately, will um, sort of overwhelm the system with organic matter or with oxygen. It will make the microbes go into sort of hyperdrive and mixing the soil too, mixing the particles, uh, sort of makes more substrate for the organisms to start taking over, and then their population will grow. So it's just kind of a known thing that tillage or other disturbance will increase the microbial decomposition of the soil and actually the oxidation of the organic matter, just by exposure to oxygen. And it will kind of disrupt uh, all the networks and all the interactions that are already in place there. So I mean that's sort of my way of probably trying not to answer the question by answering the question, but it's if you prepare for tillage, by doing things to the soil to improve the organic matter content, this decomposition rate will increase, but perhaps there's still enough supply that you won't lose a significant amount, and the soil function will not decrease. That's the idea that at some point, if organic matter can be added to the soil to sort of negate the effects of that tillage, that's that may work, that may be okay. We do try to promote things like conservation tillage, minimum tillage, no-till, cover crops, things to keep the soil covered and keep it intact, sort of in its current state without disturbance. But that being said, sometimes you do have to till the soil, and we have to be honest about that. That in some cases you have to till the soil, and if you just make the soil somehow more resilient, so when you do till it, the losses won't be so great. It's when soils are tilled every year, residue is not left behind, and the organic matter content just keeps dropping and dropping and dropping until there's almost none. That's when soil function starts to get impaired, and that's when tillage can become a negative impact on the soil. So I don't know if that was.
Thank you. Perfect.
Okay.
So I'm going to save the rest. I have a couple more questions, but I'm going to save them
Okay.
and let you continue with your program. But I will be back in touch with you.
Right. Very good. Thank you, Becky. Okay. Thanks for all the questions too. So, all right. So yeah, one thing we were talking about, and that Miss may or may not be impacted by disturbance, but this is one of those things. If you ever heard of a food web for other ecosystems, the soil essentially is an ecosystem. That's one thing we didn't really talk about. We use the terms dirt and soil, and what is dirt versus what is soil. Dirt is technically displaced soil. So if you disturb your soil, dig a hole in it and the spoil pile is dirt, it's no longer soil. And the reason it's soil is that the physical, chemical, and biological properties have all been sort of established. Again, not static. They're dynamic, but in a situation where all parts of the system are sort of working together. That's kind of what makes a soil and not dirt, because it's alive and it's supporting life at all different levels. And our idea, NRCS's idea of the soil food web is shown here. It's different trophic levels, everything, including the organic matter and the plants, which are going to be our contributors to the organic compounds, and then everything that either interacts with, consumes the organic matter, or breaks the organic matter down, or at higher trophic levels consumes what is interacting with the organic matter. So just like any other web, you break a piece of the web, you take a piece of it away, the web starts to fall apart. Not every player will be, in every soil, but one way to think about it, you don't want a system where one part of the web is dominant over the others. Everything kind of goes, we try to use the word, I guess, imbalance. You don't want the system to go into imbalance. But here, anything that might be consuming or taking away biomass within the soil food web is also going to affect the organic matter content of the soil. So you don't want too many of these organisms interacting too much with the plants either. These guys are going to have to be kept in check as well, so that the plants are allowed to produce biomass and to produce those organic compounds. So everything is balanced here as much as possible, and as much as we can in such a dynamic system. So we talked about how you can decrease organic matter. Remember, it's a loss of biomass, decreased production of plant materials. Well, obviously, to get more organic matter into the soil, you can increase the production of plant materials. You can do things carefully through soil testing to guide you, and through, you may have to add things. People mentioned the pine barrens. Your soils may be a little on the droughty side, may need a little help from irrigation water, add a little bit of fertilization to help the plants achieve more biomass production, using cover crops that kind of help. They're sort of like little companion crops that keep the soil covered. They're not the crop that you're harvesting, but they're there all the time, producing biomass, keeping the soil covered, contributing to the soil staying alive. Increase the plant density. You can add more plants, pack those plants in more tightly. That'll definitely depend on plant species. Not every plant's going to want a competition from its neighbors, but as much as you can. and then growing plants that produce more biomass. So typically, it may not have anything to do with agriculture or gardening, but it seems like herbaceous plants, I think grasses tend to produce the most biomass per, I guess, per plant, per unit plant. So where you can try to find perhaps some plant species that produce a lot of biomass. You can increase the supply of organic materials. Here again, don't let that organic matter be the residues taken off either inadvertently or through the actions of insects and rodents, which is an imbalance to the food web. You can apply animal manures or other carbon-rich wastes, things that may not be things anyone else wants to use. You could apply those to your soil. Those would also have to be monitored, of course, too. But those are a source of organic matter that's not already on the site that can be added. And applying plant materials from other areas, and this is sort of a tease for something a little later, through mulch and compost. And another way to keep that organic matter in the soil is to decrease the decomposition rate. And here, kind of what we were talking about before, try not to disturb the soil too much if that's possible. Keep the soil intact, keep a vegetative cover on the soil. And an interesting thing about the vegetative cover, it keeps the soil surface cooler, increasing the soil temperature, can increase the microbial activity, and also dry the soil out more. So vegetative cover can help keep the soil cool and actually can keep the soil a little bit more moist as well. So there are some ways to help keep that organic matter higher in your soil. So here's an example. These are actually from a desert situation. So here we're working with plants, trying to add a diversity of plants to cover. You don't have a lot of rain here. You've got a lot of heat and low humidity. So they tried to diversify the plant cover, try to keep as much of the soil surface covered as possible, and leaving that soil not only covered, but leaving the plants in place, letting them grow, drop dead tissue, leaving it on the ground, allowing those different trophic levels to take it on, attack it, and transform it into the different organic matter forms that the soil needs. If you don't diversify your plants, you have low plant density, leaving some of the areas uncovered, bare soil. Soil temperatures are increasing, water content is decreasing, and you can actually see the soil itself, the bare soil without any kind of coverage, without any kind of organic matter addition, nothing to keep the soil cool. You're just not keeping that organic matter content high. So this photo just sort of made me chuckle a little bit. It's kind of hard to tell what's going on here, but this is a vegetable operation, and they are really using every inch of this field as much as they can. There are crops growing. I unfortunately, I guess my strength is soil science, but I don't know much about plants. So unfortunately, I'm not sure what's going on here. I believe this is a crop of some sort of herb or something, and then in somewhere in between there's some perhaps some odd-looking plants. They could be construed as weeds, but those are actually little spaces in between plots where the vegetables are growing, where they're just keeping, that might even be a travel area in between planting plots, and they're keeping everything covered. They just don't want to leave any bare soil out there. They want to cover everything, and even after some of the vegetation is harvested, these little rows in the middle, in between the plots, are still contributing organic matter, at least in that space. And I believe, some operations, they may actually move these, like this may actually be a weed patch or just a cover crop. They're letting it go there. They may end up having to till that up to plant some sort of horticultural crop. In that case, then they may rest this field, plant a cover crop here, and not plant another harvesting crop, and then they alternate. So this one can rest, allow the cover crop to grow up, contribute all that biomass, start to build up those organic compounds, protect the soil while it's not being used, and then they'll use this plot. They may plow that all that fresh biomass under, let it go into the soil. So there, tillage in combination with that addition of biomass to sort of like protect that organic matter content, contribute something to the organic matter content. Here we talked about, high biomass crops. Here's a really lush hayfield, and some places in the United States have the luxury of many acres where they can grow an entire discrete field. Just let that grow up with high productivity plants and let that go. Let it build the soil up, and wherever possible, if you can do that. If you do need to break this ground and reuse it for some sort of agronomic or horticultural crop, it's had all that time to build the soil and add organic matter to the soil. So adding organic matter to the soil. So there's all kinds of ways we've been talking about it. You can increase the amount of plant and root production, apply carbon-rich materials to the soil, or use practices that slow the speed of decomposition, slow the decomposition rate. This was a statement from Healthy Soils Are High in Organic Matter. Increasing organic matter may well be the most important management step, no matter what else you do. And it says a farm's profitability and sustainability, but that could be for anybody. Anybody who works the land, anybody who uses their soil to produce something. So one way we can do it is by, or one of three ways we can do it are these three examples here. But they also point out that it's really hard to get all of the biomass out of a plant, and it's really hard to get all of the organic matter from that biomass into the soil, because a lot of it is released as carbon dioxide and water. And here, just as one example, it can take up to 20,000 pounds of organic inputs, such as crop residue, to increase the organic matter content of the soil 1%. So that's a lot of biomass production for very little gain of the soil. So trying to use the plants, it's not that the plants can't help, but just know that even when everything goes really well, it'd be really hard to maintain organic matter content just with vegetative cover. So that's sort of pushing us towards that middle strategy of applying carbon-rich materials to the soil. So no matter what your operation, one way to do that, to carry out this addition of organic matter, which hopefully includes available sources of material to obtain these organic matter sources, is composting. And I have to admit, I'm no expert on composting, so this is some information I found. NRCS has a backyard conservation website, and there's some really good information there. But one way you can achieve organic matter, obtain organic matter to add to your soil, is by composting. So they have one type of composting called cold composting, where you simply pick up your yard debris, put it in a pile. You can add to it anytime, and just let it go, let it break down. It will break that organic matter down over time. It just could take a really long time. It's good if you don't have a lot of time to manage such a thing, but perhaps you have a site that produces a lot of organic source material, especially something like leaves, that were mentioned earlier. You can rake up those leaves, any kind of organic material that can be added to the pile, and you just need that time to let it break down. One thing they said is it's a low temperature decomposition, so you throw a lot of different sources on there. If there's any weed seeds or disease-causing organisms, they won't be destroyed by this cold composting. But it's one way to go, especially if you just want to start to try to do something like this. So the organic, another way to break the organic matter down more quickly is to use hot composting. This is a little more involved. You usually need some sort of a special composting bin or containment system. Moisture and oxygen are part of the system. So there's a lot more inputs and a lot more management of this. But the heat that's created will destroy many weed seeds, break those down, and eventually create humus Sorry, I knew I was going to say that. And disease organisms. So it'll be a much cleaner product, and it gets produced a lot more quickly than the cold composting will allow that. So the other way to obtain organic matter in a little less direct way, but sort of this is sort of like the adding the biomass to the soil surface. Instead of just allowing the plants to do it, you're going to add some to the soil surfaces on your own. So mulching is great, especially if you do work with bare soil situations where you have had to till. You can apply mulch to the soil surface of that bare soil, and then that helps protect it. Mulch's greatest function is to decrease the negative effects of impacts of raindrops. That pounding of the soil surface by raindrops can dislodge soil particles, and then the rainwater can carry the particles away. So and if you get a heavy enough rains, you can actually compact the soil surface through those raindrop impacts. It also sort of provides a little moisture blanket on top of the soil. So if you water your garden, you water your plants, you water your horticultural crops, it helps kind of keep the soil covered, keep it moist, and it sort of works like the vegetative cover where the plant leaves will actually shade the soil surface. It sort of keeps the sun from beating directly on the soil surface, and doesn't drive the moisture out of the soil. It also works as a bit of insulation. It kind of regulates the soil temperature. It will not allow weeds to grow because it's this discrete cover that is not soil. There's not mineral soil, so the weed seeds can't get started. And anything that falls on the soil surface, the ground surface, fruits or vegetables that fall or grow on the soil surface, they sit on top of that mulch and they don't get covered with soil particles, so they stay a little cleaner. Your ability to work the garden, work your field is a little nicer too, because that you're not in direct contact with the soil. And as an aesthetic, it kind of gives a finished look, especially depending on what type of mulch you're using. It could really be attractive. And the great thing is you can use all kinds of different things for mulch. So whatever you can get your hands on that might be appropriate: lawn clippings, newspaper, leaves, compost. So if you're composting already, once that's broken down, you can add that to the soil surface. Bark chips, hay straw, and pine needles are very interesting, because if you grow any kind of acid-loving plants that really love a low soil pH, you can try to use pine needles, and that will help keep the pH of the soil low, and you may not have to do anything on your own to attend to or amend the soil pH to bring it down. So that's sort of a neat side effect. All right, hopefully answer this attendee's question: how much soil organic matter is too much? And I'm glad they asked the question, because a lot of times when you look in literature, this is not something that's really emphasized. A lot of the even NRCS publications, you don't really get a sense that there's such of a thing as too much soil organic matter. I do have to say, what I'm about to say is based on soil science, but some of it is my own personal experience working with soils and interpreting soils from what I've actually seen happen to soils with too much organic matter, even in nature. So not that you have to take my words with a grain of salt, but just know that some of this is derived from NRCS information. Some of it is my personal experience. So it depends on how much you trust me and my opinion. But one thing I like to say, some of my coworkers make fun of me because I use this term, "it depends." And there's no straight answers in soil science, and part of it is the diversity of the attendees. A lot of you mentioned the types of soil you have on your property, and no two soils sounded very much alike. There was clay with stones, there was clay with clay, there was sand. So just going all over the state, not everybody has the same kind of soil, the same type of soil. So the organic matter level that is appropriate or best for the soil is actually going to relate to one of the physical properties of soil texture. But I can tell you, too much organic matter may lead to instability of the soil. Talking about support for structures, that's not specifically what we're talking about, but one function of soil is to sort of like hold things in place, and plant roots and stability for plants is really critical for what we want to use it for here. Some soils with a high organic matter content may actually not be able to support plant roots or any kind of tree or any kind of vegetation that needs to stand on its own. And another thing that can happen, too much organic matter, the organic matter can actually float in water. So if too much water sort of overwhelms the soil system, that organic matter can actually dislodge and become buoyant and float and destabilize your soil. And the other thing that can happen is that, kind of like talking about the soil organic matter content, the balance that we're looking for, sometimes you do all that work to add excessive organic matter, thinking you're helping the soil. And again, it's not a bad thing, but too much organic matter, the system may not be able to use it anyway. The microbes can only break it down so much. So it may just actually sit there and may actually just oxidize and burn off and never get utilized by anything. So it could be a road to nowhere. All that input, all that expense and energy you put towards it, you may not get a benefit from it. So here I found this from the Rutgers Soil Testing Lab. I rely on them pretty heavily because they're the ones who interact with the public. They're the ones who interact with people who use the soil. And again, I really do like to push soil testing. Soils are magical and complicated enough. The more you can learn about your soil, the better. So soil testing will help you figure this out. But this is a really interesting table, and I got it right from the Rutgers Soil Testing Lab website. But I don't know how familiar everyone is with USDA soil texture classes, but let's just say from this texture of a loamy sand down to silt loam, this is a coarser texture. The bulk of this texture is sand. This is sand with a little, sandy loam is a sand with a little bit of silt and clay perhaps mixed in. Loam is sort of a proportion of sand, silt, and clay, and not equal proportions, but sort of proportions where neither sand nor silt nor clay overwhelms the system and becomes dominant. And then you have a silt loam where the silt-sized particle, which we actually saw a long time ago, that 0.05 millimeter particle, there's a lot of silt in this particular soil. But from left to right, coarser to finer textured soil. So here, if you look, everybody's very low at less than 0.5%. But by the time you get to 1.5 to 2%, you're high for a loamy sand as far as organic matter content goes. You're still very low for silt loam. And by the time you get to 2.5 or 3 to 3.5, you're high for a loam, and you're very high for a sandy loam, and you're already very high for a loamy sand. You have to get all the way to 4 to 5% for organic matter to be high in a silt loam. And this kind of doesn't make any sense because sand particles are larger than silt particles, but the spaces in between, there are actually more spaces in between silt grains because they're so tiny versus the sand. So it would take a lot less organic matter to overwhelm a loamy sand and become too much versus a silt loam. You can add a lot more organic matter to a silt loam. Once it's sort of broken down, decomposed, and mixed into the soil particles, in amongst the soil particles, the silt loam can absorb, I guess, or take on or store a lot more organic matter than can the loamy sand. And this actually, if you've seen it in the field, in a soil, a silt loam with a very low percentage of organic matter, probably you might not even be able to really see the organic matter, but a loamy sand, you don't need to get too much where you'll actually see the organic matter mixed in with the sand grains, and you'll realize that it really is, more than enough. So I don't know if that makes any sense, but this is a really good guide, and it's just kind of a way to help you understand from a scientific measurement standpoint where organic matter needs to be. How much is too much? By this chart, based on your soil texture, which I believe you can also get from your soil testing lab, will tell you what your USDA soil texture is. It's a pretty good guide on how much organic matter you can add to your soil and still have it be beneficial without being too much. And yes, I see a question somebody asked about 100% compost, and yeah, that's about where we're going to go right now. Yeah, compost and organic matter. The organic part of soil is not mineral, and the mineral part of the soil is what provides structure and stability to the soil. So here's just a couple of examples. Here's a couple of examples of organic matter in soils where the organic matter level is just too much, and you see the effects of it. So there's other things going on with the soil, but this is one of the soil orders. There's it's a classification system for soils, but this is an organic soil. It's called a histosol. Histo is a formative element. It means tissue. I believe it's Greek or Latin. And this soil is essentially greater than 51 inches of organic material. It's basically a water body that has stagnated, eutrophied, and filled with decomposed organic matter. If you ever read a soils description of one of these, you'll see soil textures of mucky peat and muck. You won't see questions about you won't see soil textures that are mineral in nature. The loamy sand, the sandy loam, silt loam, and things like that. So organic matter is described by terms such as mucky peat and muck, and this is all organic matter. There's no mineral really content at all. And even though this also has a water table, which is affecting the soil's ability for different uses, it's the organic matter itself that is kind of determining what can grow in this soil. This is one thing I wanted to bring up too. I talked about too much organic matter being buoyant and floating in water. This water is almost the same color as the organic matter because the organic particles are floating in this water that after I dug the soil pit out and it filled with water up to this point, the organic matter is just loosely floating. So the organic matter has no ability to hold itself together, unfortunately. There's just too much of it. So this is the same site, and it is a wetland, so the tree roots cannot get down into the soil, but all around us is that cat den soil series, that muck soil. So the roots just had no opportunity to get into the soil, but because there's no mineral content, the soil is very unstable. This tree literally rocked itself back and forth until it fell. And then, the tree just had no ability to hold itself up once it reached a certain height. And this is a more typical vegetative cover for some of these organic soils. And again, like I said, there's a water table here, so upland plants will not want to grow here anyway. But it can hold these skunk cabbage plants up pretty well. But anything larger, these trees are once they get a certain size, they're going to fall over, and it's just because there's just there's not enough substance to the soil to hold the plants up, a larger plant up. So this is sort of an interesting. This is actually a study. I'm studying a forest soil up in northern New Jersey, and a more typical example of this soil. You don't have to worry about. This was from another presentation, so please don't worry about what an E horizon is, but it's more typical for this soil, a forest soil that's undisturbed, never had anything done to it. Trees are 50 to 75 years old. It starts to develop this little gray layer here, and it's just something that the soil does, and it's formed this way for hundreds of years. So even people who described the soil very long time ago saw this same exact horizon. Well, some parts of the forest where this little gray layer, this discrete gray layer is supposed to be, there seems to be an excess of organic matter built up. And also the root mat is built up to about 3 times the thickness that it normally is. It's just normally very thin. So there's some sort of imbalance going on in the system here where the soil is starting to get overwhelmed with organic matter for some reason. I haven't quite figured this out, but this little gray layer is actually becoming obscured and filled with organic material due to some sort of imbalance or change. And what's interesting, there's a change to the understory of the soil. where I don't know, in this situation where the soil is preserving this little E horizon, this little gray horizon, you typically get an understory of these little blueberry bushes. I guess they're called low bush blueberry, and they're pretty lush. Where the excess organic matter is and this overly thickened root layer, the the little low bush blueberry disappears and you get these ferns growing here. So I'm not sure what's going on here, but there's a dramatic change to the soil environment, and then also a change to the forest ecosystem. So here, it's not like we're all organic matter. There's still mineral soil mixed in here, but just that overwhelming addition of organic matter and that over thickening of the surface layer of organic, it seems to be creating some sort of a change where it's either making it undesirable for the blueberry to grow and the ferns to grow, or I'm not sure exactly what's going on there, but there you're not adding a phenomenal amount of organic matter, but something's out of balance here, and it seems to be changing the ecosystem. So there again, a little too much is too much for the system, perhaps. So in when everything's working well, in the best situation, here's a really beautiful agricultural soil, and you can see there's a surface horizon. It's a discrete horizon of topsoil. It does have some vegetative cover, but there's organic matter in there for the full extent of that, and that's creating a great root zone for plants to grow. There's enough organic matter there for all those microbial processes. There's enough organic matter being added as organic compounds and biomass, detritus to the soil, so that things are trying to stay in, things are able to stay in balance here. So when everything's working well, you get all the positive attributes of that addition of organic matter without any of those negative characteristics. And that is actually it. That was my last slide. So
Great, thank you so much for that.
you're
We
very
have a
welcome.
couple more questions.
Okay.
Some really good
Absolutely.
questions. I'm kind of trying to group them together.
Okay.
So let's see where we should start. How about on more testing, soil
Okay.
testing?
Yes.
So somebody asked about biological soil testing. So what about biological testing?
Ah.
They're actually interested in testing for the abundance, diversity, and activity of soil microorganisms. And could soil also be tested for the presence of plant pathogens, or to see if the soil is bacterial or fungal dominant? And I
Ah.
think there's types of soil tests for biology, but you are the expert.
That I have to admit, that is outside of my expertise, unfortunately. But I know that there are laboratories that will test for that. I am not sure where you would find that, and it's not a concern, but my only thing, I do not know who would test that, and I do not know if that may be expensive. Expense is like, it costs what it costs, but I do not know if there would be a large expense to be incurred by that type of testing. I almost want to say, I would almost say talk to Rutgers Cooperative Extension to see if they might know in your county. They might be someone to ask. I do not know if they would know. That almost seems like something a university would do. It may be more advanced testing. It's not that you couldn't get it done. It would actually be very interesting to do something like that, to really know, yeah, how is your food web functioning? What players are there? It is a good question because knowing all the players in your food web, all the participants, yeah, you definitely don't want an all fungal system, and you definitely don't want an all bacterial system, because they will throw everything into out of balance and outcompete everything else, and basically they could change the fertility and the dynamics of the soil itself. So you would have to do something to bring them all back into balance. So So knowing the concentration would definitely be a good idea. Yeah, pathogens too. It's like I'm trying to think like someone like a cooperative extension or a crop scouting, organization, something like that. I don't know how specialized it would be, but I can't off the top of my head think where you would get that done. But
So
definitely a good
we
question.
actually have some of your colleagues tuned in to watch the program.
Wow.
Dr. Stephanie Murphy is here or was here. She had offered earlier a fact sheet to refer to about the detriments of too much organic matter. So I put the link in the chat to that.
Oh,
And
great.
then Eileen Miller is also tuning in, another soil health scientist, expert.
Yeah,
And
definitely.
she has suggested Cornell and Rutgers to test soil for um, soil
Okay.
biology. So, and she also just put a link in the chat
Oh, great.
to
Terrific.
all panelists. I'm going to actually just copy that link right now and send it to all attendees.
Excellent.
So everybody will get that link. Great.
Thank you.
Thank you. Yeah, soil biology. Actually, that was what Dr. Crumans was talking about last month at our previous webinar number 1.
Very good.
So hers wasn't recorded, but we would definitely love to have her back sometime. So
Yeah,
when we do,
it's a
she's a
full
soil
subject. Yeah.
biology person. Yes.
Yes.
Okay. So a couple more questions.
Okay.
One was you had started talking about different soil textures several times during your presentation, and you
Yes.
mentioned loamy sand and sandy loam, and there's a lot of other definitions that sound real similar to each other. What's the difference between a loamy sand and a sandy loam?
Okay. So yeah, I was afraid to spend too much time on that, but yeah, unfortunately those terms are a bit foreign and confusing. But yeah, so U.S. Department of Agriculture has what are called soil texture classes, and basically what a soil texture is, it's the mineral part of the soil. So here we've been talking about organic matter the entire time, but it's that mineral fraction of the soil that is technically less than 2 millimeters in diameter. The largest particles are sand particles. They go from little less than 2 millimeters to 0.05 millimeters. There's a silt particle, which is a little bit smaller than a sand particle. That goes from 0.05 millimeters to 0.0002, I think. It's 2 microns. And then the smallest particle, which starts at 2 microns, is the clay particle. Clay particles are microscopic, so you can't see an individual particle. So sand is huge compared to silt and clay. So all soils sort of inherited the soil texture based on what material they formed from. But it's the mineral part. It's not organic in nature at all when we talk about soil texture. So what happens is in nature, as the soil is created, different proportions of sand, silt, and clay get mixed together, and whatever the proportion is of each one of those as a percent, they come out as different soil texture classes. So in general, the phrase loamy sand, it's basically a sand texture. So the majority of that soil is sand, much greater than 50%. Perhaps more like 80% of that soil is made up of sand particles, but there's also a small percentage of silt and clay mixed in there, which gives it the loamy sort of descriptor. But it's a sand texture. Then we get into loam textures, and they are a higher proportion, more of an equal proportion, but not equal proportion of sand, silt, and clay. We have a loam texture, which that's always very misunderstood. People think loam is an equal proportion of sand, silt, and clay. What it is, it's a mixture of a percentage of sand, silt, and clay, such that there's enough sand in the soil to kind of break the soil up and aerate it and allow water to move through it more freely, but not so much sand that it makes the soil droughty or infertile. There's some clay in the soil, but not so much that it makes the soil sticky and hard. And the people who work with clay soils, my heart goes out to them because I know how difficult clay soils are to work. They're sticky when they're wet and they're hard as concrete when they're dry. So there's like no good time to work a clay soil. So loam has a little bit of clay to hold the soil together, but not so much that it gets sticky or hard to work. And then has enough silt to kind of like fill in the middle parts where it kind of softens the soil up a little bit, but there's not so much silt that the soil takes on too many characteristics of silt. Silt is actually the one particle in soil that makes soils erodible. When you feel a silty soil, it feels nice and soft and floury and powdery, but silt is a soil particle that it can actually become buoyant in water. And if you ever went past a bare soil area and water is running off of the site and the water has the same color as the soil that it ran off of, the particles in that water are silt particles. So silt makes soils very erodible. So loam has like all the best percentages of sandstone clay, such that none of the particle sizes overwhelm the soil. They all kind of work together. And a lot of people say loam is the best soil agriculturally or to grow crops. And that's another comment where I throw "it depends" in there, because not every soil is going to like a loam. Some soils like sandier soils, or some plants like sandier soils, some like siltier. So here I mentioned silt. So if you add an excessive amount of silt, approximately greater than 50% silt, it'll still be a loam. So it'll still have some sand and clay mixed in, but a lot of the soil is made up of silt now. And there's other texture classes. There's clay loam, sandy clay loam. There's sand, which is predominantly sand. And there's also clay, which is predominantly clay. And it's where this proportion of sandstone clay come out. If you get your soil tested by the Rutgers Soil Testing Lab, they actually run a particle size distribution analysis, a PSDA on it, where they break the soil down into its constituent parts, and they will tell you the proportions of sandstone clay, and then they will determine for you the USDA soil texture class. But the only reason we care about what the actual soil texture is that it speaks to the soil's behavior. We'll know a little bit more. A loamy sand is going to be more droughty and infertile. You may have to irrigate this soil. You may have to add more nutrients to this soil, and the nutrients may not stay. Whereas with a silt loam, that may not even need irrigation. That may hold on to water all by itself just fine. And it may be able to, because of the clay content, it may be able to hold on to nutrients through cation exchange capacity, and it'll just function. It may actually be a more fertile soil. But we also know, because it has a lot of silt in it, that we need to watch out and protect that soil and not let it erode, because the chances of this soil eroding are much greater because of the silt content, which is hinted by the name, but would actually be told to you by the proportion of silt in the soil. So I don't know, did that answer the question? Kind of felt like I went on there, but
Definitely, thank you.
Okay, welcome.
And another suggestion from Christine Rabe. She's actually the district director of the Ocean County Soil Conservation District, and she's tuned in tonight. We have everybody here tonight. It's great.
Yeah, really, that's awesome.
She suggested to do a jar test at home to determine your own soil texture, which is pretty easy. Put some a soil sample from your yard into a jar and fill it with water and cap it and shake it. And as the soil particles fall, the heavier, larger ones will fall first, the sand, and then the silt, and then the clay after 24 or 48 hours. And then
since it's just the 76 of us, I can admit something. Some of you know me. NRCS has a Earth Team volunteer program where you sign up. You could be a volunteer, and once you sign up, you're official, and you can go out and work with anyone from NRCS or USDA. So I had an Earth Team volunteer helping me with soils work, and she mentioned the jar test to me, and I was like, "What's the jar test?" And she could not believe, a supposed, soils expert, with you know, certain level of education and years of experience. She's like, you have no idea what I'm talking about. So she had to show me what the jar. She actually gave me a mayonnaise jar and showed me the jar test, and I'm like, I have never seen that in my life. But yeah, it's really neat. And you know, the way particle size distribution analysis goes, you can do a method where it's a column of water, and you kind of pulverize and break down the soil sample essentially, and then add it to the column of water, agitate it, and then it like Becky said, you time it, and I'm probably gonna get this wrong, but within about 30 seconds, all of the sand basically settles out of the sample, and then after about, I don't know, 4 to 6 hours, I believe all the silt will settle out, and then yeah, after about 24 hours the clay may settle out or may actually stay in suspension. So if there's enough clay, the water column may still be cloudy with clay, but you sort of shoot for different time periods. But yeah, if you have a, let's say you have a loamy sand, and like Christine says, you take a jar, you fill it with water, you put your loamy sand in it, you shake it up in about 30 seconds, like the majority of that sample is going to be in the bottom of the jar, and a little bit of cloudy water will remain above, but most of the sand will fall out very quickly. If you have a clay loam, you may have to really break that soil to dry it and pulverize it and then add it to the water column, and you could sit there for a day or two. I actually have a sample. Um, I have these different jars full of different soil samples. I actually added a dispersing agent to them and shook them up and then let them sit. And I had one sample that wouldn't settle out after 24 hours, and I for some reason I never shook the jar again. I just was carrying it around to different presentations, and I actually wrote the date that I actually initially shook that, and then I never shook it again. And after about a year and a half, it looked essentially the same. And I started making a contest out of it when I went to a presentation. And I'd say, like, how long do you think it's been since I've shaken this jar? And people would be like, a week, you know, a day. And I'm like, a year and a half, and it looks exactly the same. So that clay is sort of ionically bonded to the water molecules, and it will not let go. So the clay particles are still suspended in the water column, and they will not fall out. So the clay can stay suspended for a very long time. And the more clay you have, the, you know, perhaps the longer it will stay suspended. But yeah, it's a really good suggestion, the jar test, to give you a really quick sense of like what your soil might have in it. So yeah, that's a neat suggestion, definitely.
Great. Our attendees, our guests tonight, are actually sharing some nice links and asking their questions about the links. So there's a link shared for taking the soil sample, you know, the initial sample you want to put in the jar. So that link is now shared in the chat on the Rutgers website. And then somebody else shared the soil jar testing at home. That's actually a link to Clemson. If anybody can Google quicker than me and find the Rutgers one, we'll certainly put that one up there.
Yeah.
And Dr. Murphy is sharing some information on settling time in relation to the depth of the water column. So I just added that up too.
Terrific.
So we're so excited to have all these experts with us here tonight.
I know.
So I'm going to get to a question that I'm glad this person asked it, because I wonder about it myself, and it's regarding mulch.
Yes.
And the question is, does mulch take away nitrogen from the soil? I had heard different things.
That I have to admit, I'm not terribly well versed on that. One of my failings is that I guess one of my strengths is that I'm a lot more comfortable and more knowledgeable about the physical and chemical properties of soil. Unfortunately, the biological is something I've had to learn over time. But I do believe that there are probably certain sources of mulch that may they may actually contain nitrogen, and during their breakdown or decomposition, they may release nitrogen either on their own or as microbes are consuming them. So something, you know, there's the carbon nitrogen ratio of different organic materials, and something with a high, like I said, something with a lot of nitrogen could inadvertently release nitrogen to the soil as it's decomposing, and sort of throw things out of whack. They may they may be decomposed, uh, and then once that nitrogen, it kind of like there's like a nitrogen flush, and then that could throw things out of whack, and may put the microbes into hyperdrive, and then they'll excessively decompose the remaining organic matter. So and something that has a lot of carbon and not a lot of nitrogen, that conversely, through decomposition or metabolism, that could consume a lot of nitrogen from the soil and tie it up. So yeah, I think there's something in there about the carbon nitrogen ratio of different types of mulch material. And yeah, I think that in conjunction with soil testing, that may guide you towards a particular organic material to use as mulch material. Yeah, not every type of mulch is appropriate for every type of soil. So I'm hoping that between Rutgers Cooperative Extension, providing guidance, and soil testing, there's a way to like piece that all together, but probably would be better to get your soil tested and talk to somebody before just grabbing some form of mulch and just start throwing it down there. So, in the one case we talked about the pine needles too, maybe affecting the pH of the soil. It could disrupt the pH of the soil, and that affects fertility and plant growth. So yeah, I would look to other experts for that, but yeah, but there definitely is something to that, absolutely.
So kind of related question, mulch
Okay.
or substitutes for mulch anyway, such as newspaper. Common question is, what about the ink in the newspaper? Does it seep out of the newspaper and into the soil? Does that have a big effect? Don't know if that's something in your wheelhouse. Have you heard that before?
No, I have to admit, it was funny when I was doing this when I was preparing this presentation, that thought came across, it popped into my mind, and I meant to look it up and I didn't, so I apologize for that. But I did read a couple different articles on mulching, and newspaper came up a lot, and I don't know if it came up a lot because it could be a common source. Like a lot of people might have access to newspapers when you have access to nothing else. There was actually more information I was going to provide on mulching, but I was afraid to put too much because I definitely don't want to appear like an expert on mulching. So I was afraid to go too far down the road because then I have to, like, more information I put, the more I have to explain. But I know for one thing, newspapers, I think the big thing they pointed out about newspapers is that they don't want you to put a thick layer of them. A little thin layer of newspaper. I think it was less than an inch. It was like a half an inch or a quarter of an inch of newspaper went a long way. And it doesn't stay forever either. You want it to cover, so that you're essentially covering the ground. Like in lieu of vegetative cover of living plants, you basically do not want any bare soil. So if you have a discrete plant sticking up out of the ground, you piece that newspaper all around the base of it and cover over any bare soil. Mulch is just can literally be bare soil cover. So I think in that sense, you're thinking anything that you can cover the soil with. So a discrete layer of leaves, you could probably put a couple inches of leaves down, but again, you would not want to put too much. You don't want to overwhelm the system. You kind of want to think in terms of like, I want to put that down, but I don't want it to stay there forever. So it's like a thin layer of newspaper. Eventually, that's going to break down on its own, and then you can kind of like work that into the soil. The same with leaves, like a really thick layer of leaves is just probably going to sit there, for a really long time unless there's enough decomposers to attack it. And then it could just reach a point where it's too much. It would just overwhelm everything and not allow anything to grow. So some of it, I'm guessing, some of it is sort of experimenting too. What is most of it? You may have a very active soil that's just chock full of decomposers, and it may take on all the organic matter you add to it, like kind of depending on the situation. One thing I found with soil science is like there's two words you can't use with soils, and it's always and never. You can't say, this soil would never do this, because the next thing you know, it'll do it. It will defy soil physics, chemistry, and biology, and it will do something completely unintentional. So some of it is, you can't get too serious about soils either. Like it's time for you to play. Like approach it lightly. Don't get too bent out of shape about things. There's so many unknowns about soil. It's sometimes it's just you try it, just try it to see if it works. So doesn't mean don't get your soil tested, but
Right,
but there's room
right.
for
Thank you.
play too. So
Dr. Murphy did add something to the chat, and I'm not quite sure if our chat is set up so that everybody can see all comments, but I'm going to just pass it along. She said that she believes newsprint is no longer a problem and that the ink does not contain any metals any longer and that it's safe. So that's good to know. And then some other folks are suggesting to plant native ground covers instead as an alternative if the point is to the mulch is covering the soil or the newspaper's covering the soil.
definitely.
So that's always a great idea. And so here's where I plug Jersey Friendly Yards. So jerseyyards.org. And we have a great database that you can use searchable filters and determine the exact conditions in your own yard, what kind of soil moisture, soil pH, and then match those up with appropriate native plantings, including ground covers. So that's jerseyyards.org. And then I have maybe one or two more questions. Thank you so much for all your time, Fred. We're way beyond our 8 o'clock
Oh,
hour.
no,
But,
I was afraid I was taking too much time. So yeah, that's perfectly fine.
So let's see. It was another mulch type question, or I'll just say ground cover question to,
Okay.
I believe is the purpose to deter weed growth.
Yes.
A novice gardener had asked that somebody had suggested to them to use something called geotextile. I didn't know what that was, so I asked for further clarification. And basically, they said it was kind of like a weed barrier. So it sounds like the same concept as mulch, but is not sure if there's any benefits or detriments to it when you're, completely covering up your soil with, a weed barrier.
Yeah.
What are
I
your
think
thoughts on that?
the only thing I can say about that, without hopefully sounding deriding or insulting, is that I believe the idea, the most beneficial thing to do to cover your soil is something organic in nature, uh, or in composition. And the only reason it's not like you want it to go away. You're not adding it to go away. But I do kind of feel like there's that idea that even if it's a really stable form of organic matter, like bark chips or something, like eventually that's going to break down. And not that it goes away, you don't want it to go away, but it's contributing organic matter to the soil. So not that you can't use a non-organic material, which I'm assuming that's what this is. It's like, it's not that it's a bad thing, but by adding something natural, something organic in composition, you know, uh, it will eventually contribute organic matter to the soil. So it's a source of organic matter, kind of along the lines of that, adding organic matter from the outside as opposed to relying on biomass, to of the growing vegetation there. So it's a carbon rich material you add to the soil. So I think that's the only reason. I mean, I'm not gonna say, like, oh, it's a bad thing, it's going to stay in the soil for 10,000 years, and like, it has a job to do. But I think it's just that idea that it's there, and it will definitely be beneficial, but it's not really, outside of being a barrier, it's not doing anything to the soil. It's not helping that soil build itself up, add more organic matter to the soil, or help keep that organic matter in place. It doesn't do anything to the organic matter content balance. So not to
Does it,
say, I'm sorry, go ahead. Yeah.
Does it heat up the soil, or does it change the temperature and have an effect, maybe a negative effect on the soil biology below?
I
Having kind of,
mean,
the black, you know,
yeah, I mean, I do wonder. I mean, I think there is it does make sense that a dark colored material, I think even dark colored mulch, uh, may increase the soil temperature, but yeah, that's a really good point. If anything, if it was had the ability to reflect or bounce back light as opposed to absorb it and sort of put it into the soil. Yeah, I think that would be a really big concern, Becky, if that was on the soil and then after a time period or during the drier parts of the year, if that was actually heating the soil up, um, then as you heat the soil up, it does increase the decomposition rate of the organic matter in the soil, and it could increase the microbial activity, and it could also dry the soil out. If the soil is not allowed to stay cool and moist, that drier environment will sort of oxidize and burn off the organic matter. So yeah, it could inadvertently, decrease have the effect of decreasing the organic matter composition. So yeah, that's it's definitely something to think about. If it doesn't if it's not helping to keep that organic matter content stable or add to it, there's a good chance it could take away. So yeah, that was something that would have to be looked at if you use it. Not saying you can't, but yeah, there just may not be there may be situations where it's not the best technology.
Great. Thank you, Fred.
You're
I
welcome.
want to address one more topic, compost, go back to compost, and
Okay.
then I think that's a wrap. But so regarding compost, somebody wrote in and said that they used, I'll say, the township compost, which is basically, residents' leaves and trees and organic matter in
Okay.
their own
Yeah.
flower beds. Um, but they're wondering how safe it might be to use the compost in their vegetable garden. And Dr. Yergeau offered a link to the Rutgers Soil Testing Lab and said that it does provide tests for compost as well as soil, so that's good to know.
That's good.
And that's the same soil testing lab link in the chat. So then somebody asked about a RAPI test. I'm not sure, Fred, if you know what the RAPI test is. I do, because I work with school kids, and the RAPI tests are, those fun little kits where you get your soil sample, or, and you add water and you add the pills, and then you shake up
Oh, okay. Okay. Yes. Yes.
container, and then it turns color and you try to match up. So those tests actually measure pH and nutrients, NPK.
Oh, okay.
So they're wondering if that RAPI test, soil test kit, can also be used on compost. And I honestly don't know. It's
Yeah.
I would probably say not, but I honestly don't know. Certainly you could try it and see what happens, but
Yeah. I'm
testing
gonna
lab would
say
be your best bet.
yeah. I mean, you could read the test itself, or information on the test may actually tell you, yeah, it's only for mineral soils. Not for organics. Organics, organic, the organic portion of soil definitely behaves uh, differently, and it needs to be handled and tested differently. I think, yeah, even for our the soil survey side of NRCS that I used to work for, we actually have a laboratory in Lincoln, Nebraska, and their assessments or analysis of organic matter are like completely separate from mineral. And so I'm going to say anything that could be used for a mineral soil probably could not be used for an organic soil, or any, or organic material. But not to say you can't. I mean, I shouldn't tell anybody this, but I was doing a soils investigation in a part of the state where there are actually acid producing soils, where the soil itself can produce acid in the presence of oxygen. And we were evaluating a pond, and someone wanted to know if the water in the pond was acidic. And I had a Cornell soil pH test kit, and I put some water in the little, if you know what a Cornell kit, it has a little white spot plate, and you add reagent to it, and it's colorimetrics. You compare it kind of like what Becky's talking about with the rapid test. And I quote unquote tested the pH of the water using a Cornell pH kit. And I told everybody there, I said, do not ever do this. I said, this is not appropriate, but I said, I just thought it might give us an idea what's going on in the water. But yeah, it's not like I'm a trained professional and, don't try this at home. Like, yeah, don't do that at all. But yeah, I mean, you could probably try to test it and just see what happens. I don't know. It'd actually be interesting. Who
Yeah.
knows? But yeah, if there's an actual place that could test compost, and yeah, I think anytime, not that it's bad to get organic matter or even soil from foreign sources, but if the source facility or place does not test the compost before they provide it to you, probably getting it tested is probably a good idea. Ornamentals, just plants to grow for the aesthetics of them are probably fine, unless you don't want something to be in there that would hurt the plants. But yeah, anything that you plan to grow that you're going to consume, you're like, absolutely, you want to know absolutely everything about that. And that's for
And,
any parcel of land. You
yeah.
want to do that everywhere. So
That's a really good point. Also about where you're getting your compost. I know that in Ocean County, um, where we get our county sources, I am 99.9% sure that they actually test the compost. As they turn it over, as they receive new. I feel like I've been handed that test before. The results of the test before. A couple of
yeah,
years ago. So do look into that, folks out there who are asking that question. Good question.
yeah,
One
yeah.
more,
This,
one
yeah,
more, Fred, and then we're I think we're and then it's a wrap. So
okay.
what about adding high carbon content biochar and other related organic carbon to soil? That's just something I have no idea about. High
I
carbon
know
content
that's
biochar.
pretty new, and I NRCS is starting to look into that. I have to admit, I'm definitely not well versed on that. Uh, I yeah, that would require some research to look into. It seems to be a very hot topic. In fact, the topic of soil health or soil quality, which we didn't, I don't specifically talk about things like that. But all of this, a lot of this information I got is from soil health trainings and things like that. And biochar has just recently become a topic. And so, from a soil health, soil quality standpoint, our regional offices or technical centers are starting to look into that as a source. And it's not like it's a bad thing. They're just sort of approaching it with, as another possible source. And I think it's along the lines of, the kind of it depends. Biochar may be more agreeable for certain soil textures, certain soil pHs. I'm not sure exactly. Does biochar, is that active? Does it provide kind of an exchange capacity too? Is it something that, do we have to know the form of it, the source of it, the particle size of it? There's probably a lot of things to figure out about it. What is it? What is its residence time in the soil? Is it stable? Does it not want to break down? So if you put it in, is it essentially non-reactive? Will it just sort of sit in the soil? It won't combine and become part of the soil. So there's just a lot of questions to ask about it. But that's
Always something new
definitely,
to learn.
yeah, it's not a bad thing. In fact, anyone who's interested in pursuing using biochar, like I said, it seems like, at least to me, it's only come up in maybe the last year or two, and a lot of that was at the research level. We NRCS, the soil science part, collaborates with academia, and it seemed like a lot of it was coming from universities, from research. So as far as like practical application, I think people are starting to try to use it, but I don't know the success rate, or utilization, but it seems like an exciting new avenue to pursue. So if you're interested, definitely do some research and see what you can find out about it. As an attendee, I'm definitely not an expert. Like I never liked that term. When I started with NRCS, it was a long time ago, but um, some of the experts it seemed like this is picking on people, so I apologize, but some people who were self-proclaimed experts, it seemed like they learned a certain amount and then they stopped and they're just like, I know everything. And it's like, well, you know everything you learned, but soils are very humbling. For everything you think there's 1,000 things you'll never know. And soils hand me my head every day, trying to figure them out. But that's part of the fun of it too. I'll never be an expert, which that's perfectly fine with me.
Well,
But yeah.
you're an expert in my eyes for sure. And Fred, we can't thank you enough for offering your expertise and spending so much time with us tonight.
Oh,
And we
very
still
well.
have 53 people hanging on to your every word.
I
So
know. I saw the number wasn't dropping very fast.
for sharing all of your knowledge with us. We're just so thrilled to have you as part of our webinar series.
Well, I appreciate the invitation. Thanks to you, and thanks to you, Becky and Christine and Steve. Thank you for inviting me in and letting me be a part of it, and thank you for drumming up so many attendees. It was a real privilege to talk to so many people from all over the state. It's really flattering. So I appreciate it.
Great, thank you. And to all the attendees, thank you so much for spending time with us.
Yeah.
And we loved having Dr. Murphy and Eileen Miller and all the other experts in our chat room tonight. So everybody, please tune in May 5th. Cinco de Mayo is our next webinar, and that will be with Sandra Blaine Snow. And she's going to talk specifically about composting. So start generating those questions for Sandra, and we hope to see you on May 5th. So thanks, everyone. Have a great night.
Yeah,
and have a